And once again, we have this lovely message. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. When you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I will respond as soon as I can. All right, today we're going to be covering section 6.6, but before we do that, I'm going to ask for questions. And this morning, for whatever reason, this particular screen that I'm using has a delay on it. So what I'm going to do is I'm going to go to a different screen and hopefully it will behave better. So if it doesn't, well, we'll always wish that it had. So I'm going to change the background to that and get rid of that. And we'll add some pages. Okay. So we should be good to go. Can you all see the screen that I'm scribbling on here?
Yes.
Okay, excellent. So come on, get rid of that thing there. Come on, I'm going to erase it, change it back to black, and we should be good to go, hopefully. So what do you got for me?
Okay, so I didn't get, but I don't remember which question it was, but I wrote it down. It was 49t squared minus 28st plus 4s squared.
Hang on. I'm thinking this is giving me issues too. Maybe not. Okay, I'm going to get this figured out. My bad. I'm having a Monday apparently. All right. 49
t squared minus 28
minus
st
28s
st plus 4s squared.
4s squared. Now, I'll admit my handwriting is sloppy, but it's not that sloppy. This one is not behaving either. And you know what I'm going to do? I'm going to go back to my other screen because it was just delayed, but at least it was you could read it. So my apologies. I don't know what's wrong with it. But by the time I discovered it, to fix it, I'd have to reboot. If I reboot, everybody that's come and joined in the meeting no longer is in the meeting. Okay, here we go. So it was 49. See what's going on there with that?
Yes, it's
S. No, it was 49.
49t squared minus 28st plus 4s squared.
Yeah, it's legible, but if there's a delay on it, I don't know what the problem is. Okay, so anything else, you want me to just do the problem?
Yeah, could you just walk through the steps? Because I think I got the correct answer, but I would like to see it.
Okay, so this is a trinomial, okay? It's in standard form in terms of the variable s. It has t. It has t squared in the first term, just t in the second term, and no t at all in the third term, all right? So it's in standard form in terms of t. There's no greatest common factor. So on that list I wrote out yesterday for number 3 trinomials, it had Roman numeral 1, 2, and 3. Were you here yesterday? Did you see that?
Yes, I was on.
Okay, so Roman numeral 1 is look for perfect squares. Well, this trinomial starts with a square, it ends with a square, and there's a plus sign right there. So it could be. So I'm going to go in with the assumption that it is a perfect square, and then if it's not, I'll go back and try and factor it other ways. If it's a perfect square, it's got to have 7t and 7t at the beginning of each binomial factor. It's got to have 2s and 2s at the end of each binomial factor. Now, the middle term is negative, so my two factors have to both be negative. Have a subtraction sign in the middle, I mean. Okay, so if this is correct, let's see. There's 49t squared at the beginning, plus 4s squared at the end, but in the middle, that's negative 14st, and negative 14st is negative 28st, so it is correct. It is a perfect square trinomial, and you could write it the first way or like that.
That's the answer that I got as well. Thank you.
Yeah. Now, those of you that just tuned in, you might be thinking that the video is delayed. It's not the video. It's the board that I'm writing on. It's just got this delay going on, but the other one's not working either. Ah, well.
I also have one more question on the homework as well.
Sure.
It is 4x squared plus 9.
All right. So this is a binomial. So I'm looking for the difference of two squares, but there's not a subtraction sign in the middle, so it's not the difference. It's the sum of two squares, but there's no greatest common factor, so I can't take out a greatest common factor. I can't factor it as the sum of two squares, so basically it is prime.
All right, thank you.
You're welcome. Any other questions from yesterday? Anybody? Anything at all? Okay, then we shall go on to the next section, which is 6.6. And 6.6 basically throws it all together. We looked at taking out the greatest common factor and factoring by grouping in 6.1. 6.2, we looked at factoring trinomials with a leading coefficient of a 1. 6.3, we looked at two different methods of factoring trinomials with a leading coefficient other than a 1. 6.4, yesterday we looked at perfect square trinomials and the difference of two squares. And now we're going to just pull out problems and take them through that list. Do you need me to copy down that list again that I had there yesterday? Okay, well then I will just verbalize it as we go along, okay? So I'm just going to pull a problem out and do it. Let's see here. We have 8m squared n cubed minus 24m n to the fourth power. So the first thing I notice is that this is a binomial. Not only that, it has a subtraction sign in the middle. So I'm thinking difference of two squares, maybe. All right, but before I do that, I see that there's a greatest common factor. I can take out an 8 and an m and an n cubed. When I do that, my leftovers are going to be m minus 3n. Well, what I've got left over is not the difference of two squares. I can't do anything more with it. So all I could really do here was to take out the greatest common factor. Any questions about this problem? Okay, let's take a look at another one. 6r squared plus 3rs minus 18s squared. Here we have a trinomial. It is in standard form in terms of r. It has r squared in the first term, r in the second term, no r at all in the third term. Ah, but there's a greatest common factor. What is it?
3.
So we'll take out a 3, which will give us 2r r squared plus rs minus 6s squared. Now, inside is still a trinomial in standard form. Well, 2r squared is not a square, is it? So it's not a perfect square. It doesn't have a leading coefficient of a 1. So I'm going to have to use grouping, okay? Or guess and check, or what is it? Guess and, yeah, trial and check or whatever. Let's see, was it Diana, was it you that asked for this one?
Similar.
Or who was it that asked for this one? No, wait, I'm sorry. I put it up there. Sorry, this whole thing with the board all screwed up has just got me distracted. Okay, it's not a perfect square trinomial, so I'm going to factor it, and I'm going to use grouping, and then I'll go back, and if you want me to use the trial and check method, I'll do it that way as well. So you tell me. That was why I was asking who did it, but it was me that put it up here in the first place. All right. A is 2. B is 1. C is -6. The product is -12, and the sum is 1. Okay? We all right with that? So my two numbers are 4 and -3. So now I'm going to have 3, and then 2r squared plus 4rs minus 3rs minus 6s squared. Any question how I got those two middle terms? All right. I'm going to use factoring by grouping in the middle. So now I've got 3 on the outside. The greatest common factor of the first two terms is 2r. Leftovers r plus 2s. So my leftovers over on the right are going to be r plus 2s. And I'm going to have a minus 3s outside. Okay. So now I've got a 3 from the outside, then this greatest common factor, r plus 2s, and then the leftovers, 2r minus 3s. So there's the final answer. And again, those second and third factors could be commuted because multiplication is commutative. Any questions about this problem? Do any of you want me to go back and use the trial and check method instead of the grouping method on this problem? All right. Here comes another one. T minus 90 plus t squared. This is a trinomial, but it's not in standard form. So the first thing I'm going to do is put it in standard form. All right. It does not have a greatest common factor. It's not a perfect square, but it does have a leading coefficient of a 1. So back in section 6.2, we take that first term and split it up. Now we're looking for a product that's -90 and a sum that's 1. So we're not using grouping. We don't need to use grouping unless that leading term has a coefficient other than a 1. So my two numbers here are going to be 10 and -9. Multiplied together, they're -90. Added together, they're 1. So I put those numbers right in my factors, and we're done. Any questions on that problem? Okay. Here's a new one. A b squared minus 4a plus 3b squared minus 12. 4 terms. Typically, 4 terms we use factored by grouping. Well, is there a greatest common factor of all 4 terms? No. So let's see what happens if we just break it up in the order that it is right now. So we'll have 2 groups of 2. The greatest common factor of the first 2 terms is an a, and the leftovers are b squared minus 4. So let's see if I can get a b squared minus 4 as leftovers on the right side. It looks like I can with a plus 3. Any questions so far? So now I've got b squared minus 4 times a plus 3. But b squared minus 4 can be factored further as the difference of 2 squares. So b plus 2, b minus 2, and a plus 3. And now we're through. It's factored completely. Any questions on that one? A common mistake is to stop right here. So make sure you look at each thing as you're going along. Okay. Let's see here. 16 minus 40z plus 25z squared. This is another trinomial. It's not in standard form, so we'll put it in standard form. 25z squared minus 40z plus 16 . Let's see, there's no greatest common factor. It could be a perfect square. It starts with a square, ends with a square, and there's a plus sign at the front of the last term. So let's see if we can get it to be a perfect square. 5z and 5z and 4 and 4. Would the middle sign, would they both be a subtraction sign or both be a plus sign, addition sign?
Subtraction.
Right, in order to get the minus 40 here and here. And it does, so that's the answer. Or you could write it 5z minus 4 the quantity squared. All right, good to go on that one?
Yes.
And here's another one. 6t to the 4th power plus 14t cubed minus 40t squared. This is a trinomial. It's in standard form, but there's a greatest common factor. Well, if I look at the coefficients, the 6, the 14, and the 40, I see that I can take out a 2. But if I look at the t in each one, I can take out a t squared out of each term. So my greatest common factor is 2t squared. So now my leftovers are 3t squared plus 7t minus 20. So now I'm going to use grouping, or do you want me to use the trial and check method?
Grouping.
Grouping it is. Okay. A is 3, B is 7, C is negative 20, the product is negative 60, the sum is 7. Let's see. The product is negative 60, so that means there has to be a positive factor and a negative factor. The sum is 7 and it's positive, so that means the positive factor has to be bigger. I'm going to rewrite these over here where I've got more room to work. So I need a big positive and a little negative. Well, that would give me a sum of 59, and that's not right. I could take 60 and cut it in half and get 30. If I cut that one in half, I have to double the other one. So that still gives me a product of negative 60. My sum is down to 28. Well, let's see, 30 is even. I can cut that in half and consequently double that. So now I've got a sum of 11. Well, shoot, I'm getting closer, but I can't cut 15 in half because it's not even. I could take out a 3 and I'd have a 5 and a negative 12. And that would give me, oh, I've got the right number, but the wrong sign. How could I do that? What if I changed this and this? Would that make that?
Yes.
Yes. So my numbers are negative 5 and 12. So now I've got, let's see, let's change to a different color here so it'll stand out. I've got 2t squared, 3t squared minus 5t plus 12t minus 20. Okay? So I split the middle term. Or yeah, and now I'm going to split this up. I've got 2t squared. My greatest common factor here is going to be t with a 3t minus 5. 3t minus 5. And let's see, there I'm going to need a plus 4. So now I've got 2t squared, 3t minus 5, t plus 4. I feel like I'm writing in thin air because I can't see what I'm writing. It doesn't show up yet. I have to really pay attention, but it's also making me go slower, so maybe that's better for you. You okay with this one? I'll take that as a yes. Let's see here. We good to go on?
Yes.
All right, excellent. A squared plus 8a plus 3. So here we have a trinomial. It's in standard form. There is no greatest common factor other than a 1. It has a leading coefficient of a 1. So that means we're going to do this. And the product needs to be 3, and the sum needs to be 8. Well, for the product to be positive, it has to be 2 positive numbers or 2 negative numbers. But the sum is positive, so we're looking for 2 positive numbers. And the only possibilities are 3 and 1, and they don't give us a sum of 8. So what's the conclusion?
Prime.
Prime. Excellent. Now, a mistake that people will make sometimes is, and maybe not so much in WebAssign, but just in writing it out on your own paper, is if they can't factor it, they just leave it alone. But you need to declare, you need to say it's prime, okay? All righty. Let's see here. Let's take a look at this one. A squared b squared minus 144. This is a binomial, and it's got a subtraction sign in the middle. So I'm not really worried about standard form, but is there a greatest common factor? Not really. But be careful, because if I were to write it like this, and again, this is not factoring it, but a squared b squared would be ab, the quantity squared, and 144 would be 12 squared. So I'm going to get ab plus 12 times ab minus 12. And ab minus 12 is a difference, but it's not the difference of 2 squares, so I can't factor it any further. To check my work again, what would I do? Multiply it together. A squared b squared minus 12ab plus 12ab minus 144. Those cancel out in the middle. A squared b squared minus 144. If I wrote fast enough, I could write the problem out, go jump in bed and take a nap and come back before it showed up. Okay, that might be pushing it a little. Oh, how about this one? 28 minus 3m minus m squared. This is a trinomial, but it is not in standard form. So I'm going to rearrange it. So now it's in standard form. Well, there isn't really a greatest common factor, but what am I going to take out?
A -1.
Correct. Take out a -1 so that my leading coefficient is positive. So now I've got a product of -28 and a sum of 3. How about, let's see, 7 and -4? Would that do it? I believe so. So +7 and -4. You could write it this way, or you could just have a negative sign without a 1 attached to it. So you could write it either one of these two ways. Okay. How about, let's see, this one. 81r to the 4th power minus 256. This is a binomial with a subtraction sign. Let's see. Does it have a greatest common factor? 81 is 9 times 9, or 3 times 3 times 3 times 3. But 2 plus 5 is 7 plus 6 is 13. So 3 doesn't go into 256. So I don't think there's a greatest common factor. So let's see here how this would look. We'd have 9r squared. 256. I'm going to take the square root of 256 and see what I get. Oh, 16. So this is, so it's 9r squared, the quantity squared, minus 16, the quantity squared. So now my factors are 9r squared plus 16 times 9r squared minus 16. But that first factor is the sum of two squares. Recall that the sum of two squares doesn't factor after you've taken out any greatest common factor. But the difference of two squares does factor. So this first factor stays the same. This next one becomes 3r plus 4, 3r minus 4. And there we have that. Now, the third factor, 3r minus 4, that is a difference. And 4 is a square, but 3r is not a square. So we're through, other than to check it, multiply it out. Do you want me to multiply it all back together?
No, I'm okay with that.
All right, then I won't bother. I'll just be lazy. Take a look at this next one. 12x squared plus 14x minus 6. So here we have a trinomial in standard form, but it has a greatest common factor of a 2. The trinomial that's left over has a leading coefficient of something other than a 1, so I'll use grouping to factor this. A is 6, B is 2, C is -3, the product is -18, and the sum is 2. How about, let's see here. 9 and 2, 3 and 6. I want to make sure I didn't make any mistakes here. Oh, I did make a mistake. Right here, I misread this 14 up here as a 4. So this should be a 7. Yeah, I was thinking it didn't factor any further, but I messed up. Okay, we all right with that?
Yes.
Okay, so now let's see. I've got what, 9 and -2. That's a little better. 2. 6x squared plus 9x minus 2x minus 3. Split it 2 times, let's see, 3x, 2x plus 3, 2x plus 3, and a minus 1. So I've got the 2 that's the greatest common factor that we took out. I've got 2x plus 3 and 3x minus 1. All righty. Let's see here. $12x squared minus 12. This is a binomial in standard form. Careful, it's not the difference of two squares yet. But if we take out the greatest common factor, which we should do first, we see that in fact it is the difference of two squares that are left over. Good to go on?
Yep.
All right. 6x squared minus x minus 16. This is a trinomial in standard form. There's no greatest common factor. The leading coefficient is something other than a 1. So a is 6, b is -1, c is -16. The product is -96, and the sum is -1. Now, I'm going to rewrite that over here so I have more room to work. The product is negative, so I've got to have a positive and a negative factor. The sum is negative, which means the negative number has to be larger than the positive number. How much larger? Just 1, like -11 and 10, or -5 and 4 kind of thing. Well, let's just start out here. -96 and 1. That would give me -95. If I cut that in half, I get -48 and 2. That still gives me the same product, right? So now I'm down to -46. If I cut that in half, -24 and double that, that's still a product of -96. And my sum is -20. If I cut that in half and double that, I still have a product of -96 and my sum is -4. Well, I'm getting closer and closer. Let's see, -6 and 16. Oh, but really, well, let's see, that would give me what? +10. And it needs to be negative, doesn't it? What if I made this positive and that negative? That would make this negative, right? But then that would actually go right in there, wouldn't it? Because -10 here. So here's where I'm at, okay? I've worked my way down to -12 and down to +8, and I'm worked my way down to -4. I need two numbers between -12 and 8 whose sum is -4. Well, let's see. -11 doesn't go into -96. -10 doesn't. -9 doesn't. -8 would go in, but then if I go -8 and 12, I'm already up to the positive side. Are you seeing what I'm concluding? What am I concluding?
That it's prime.
Yeah, that it's prime, because there's nothing in the middle there that I can find. Okay, let's see here.
Excuse me, Mr. Mayo.
Yes.
I have to go to work, so I have to leave the meeting a little bit early, but I just wanted to let you know and say thank you.
Oh, you're most welcome.
Okay.
And I'll be back at 1:15 to 2:15, or I'll be back tomorrow morning. But you have
Okay, thank
a good day
you.
at work.
You too.
All righty, take care. Okay, let's see. Now we've got this one, x to the 6th minus 4x cubed minus 12. This is still a trinomial, and it's still in standard form. There's no greatest common factor other than a 1, and it has a leading coefficient of a 1. So I'm going to split it up like that. Okay, x to the 6 becomes x cubed and x cubed. The product is negative 12 and the sum is negative 4. How about negative 6 and 2? Negative 6 and 2. And neither of those factor further, so we're done with that one. Okay. How about this one? 25b squared plus 14b plus 49 over 25. That doesn't look fun at all. Well, let's see here. It's a trinomial. It's in standard form. And it doesn't have a leading coefficient of a 1. Oh, I wonder if it's a perfect square because it starts with 25b squared. That's a square. 49 over 25, 49 is a square, 25 is a square, so 49 over 25 is a square, and a plus sign. Well, here's hoping. All right, 5b, 5b. The square root of 49 is 7, and the square root of 25 is 5. Would it have to be a plus or a minus sign in the middle?
A plus.
Okay, let's see if that's going to work. So up the front, I've got 25b squared. At the end, I've got 49 over 25. What about this and this? Let's see. 5b times 7/5 would be 7b. And I've got 2 of those, so I've got 14b. So yeah, that's correct. Or I could also write it like that. Okie dokes.
All right, I got a question.
Yes.
So I remember multiplying fractions was like back in grade school, but how did you get 7b? Just so I'm sure I'm doing it right.
Right here?
Something like that.
Okay, so let's take the 5b times 7/5, right?
Yeah.
In the 5b, there's an implied 1 in the denominator.
So you just multiply straight across 5 times 7 and then over 5?
Right, but I could also reduce the 5s out first.
Yeah.
So I could either take 35b over 5 and get 7b, or I could just pre-reduce it and get 7b, which is what I did because I'm lazy and that's less work.
Okay, I got it now. Thank you.
All righty. And are you okay how we got the 49 over 25?
Yeah.
Okay, great. Here's another fun one for you. Fun for whom, you say? 1/4 minus u squared over 81. Well, this is a subtraction sign. It's a binomial. Greatest common factor? I don't think so. But look. Wouldn't that be 1/2? And this would be u over 9. 1/2 squared would be 1 squared over 2 squared, or 1/4. U over 9 squared would be u squared over 9 squared, u squared over 81. So I get 1/2 plus u over 9 times 1/2 minus u over 9. All right with that?
Could you show another example with the fraction? Because
Sure.
I'm not so good at fractions.
So like this one or like the previous one?
Like this one.
Okay, let's see. I've only got one in the book there, so I'll make something up. Okay, let's do 1/16 minus x squared over 25. Okay. So one 1/16 would be 1 squared over 4 squared. You okay with that?
Yes.
Yes.
X squared over 25 would be x squared over 5 squared. So now we've got 1/4 plus x over 5, 1/4 minus x over 5.
That makes more sense. Thank you.
Okay. Do you need another one?
Yeah, if you got one up your sleeve, I'll take it.
Oh, let's see what I've got up my sleeve. Oh, there's an arm. Okay. How about, oh, let's see here. 4/25 minus 9y squared over 144. Oh, things just got ugly. Ugh. 4/25. What's the square root of 4?
2,
What's the square root of 25?
5.
So 4 over 25 would be 2/5 the quantity squared. Okay. What's the square root of 9?
3.
Square root of y squared.
Y.
The square root of 144.
12.
12. Oh. There's something that I accidentally created that I can do. Is there something I can do with 3y over 12?
You can reduce it to 1/4 y.
Yeah. So in fact, this could have been y squared over 16. So then I've got 2/5 plus y over 4, 2/5 minus y over 4. And you could also write it like this, which is what you said. Instead of writing y over 4, I could write it as 1/4 y. So I could write it either way. Okay? But yeah, 9 over 144 reduces down, so you should do that either at the beginning or somewhere towards the end there. We good on that, or do you want another one?
Yes, that's fine. Thank you.
All righty. Let's see here. Here's a fun one. I know I have a twisted sense of fun, don't I? X to the 4th minus 13x squared plus 36. So this is a trinomial in standard form. There's no greatest common factor, and the leading coefficient is a 1. So I'm going to split it apart, x squared, x squared. The product is 36, and the sum is -13. To get a positive product, you need 2 positive factors or 2 negative factors, but I've got a negative sum, so I've got to have 2 negative factors. How about -9 and -4? Would that do it?
Yes.
Yeah. Let's see, -9 and -4. Come on, eraser. There we go. -9 and -4. Oh, but look, x squared minus 9 is the difference of 2 squares. X plus 3, x minus 3. X squared minus 4 is the difference of 2 squares. X plus 2, x minus 2. This is like a math teacher's dream because it has all these different things in one problem that you have to do. Or maybe it's a student's nightmare, I don't know. Anyway, you okay with that?
Yes.
Let's see here. One more. X squared y squared minus 6xy minus 16. So there we have a trinomial. It is in standard form. The variable is xy, because at the front we have x squared y squared, so that would be like xy, the quantity squared, minus 6xy, and then a constant at the end, okay? So if we think of xy, sort of the combination as being the variable, we'd get that. Our product is -16 and our sum is -6. How about -8 and 2? So I get -8 and +2. The first factor is a binomial with a subtraction sign, but xy -8 is not the difference of two squares. So that's as far as we can go with that. All righty. Well, that should be enough torment for today. So I'm going to stop the recording